The next paradigm that I want to talk about is logic programming. I think that you guys took a course in programming, logic programming, Prolog. It's pretty much the only language there in this paradigm, which is uses predicates and all kinds of deducing rules and reaching some kind of logical conclusion of different predicates, and it's being used a lot in AI and other places. So this is a paradigm unto its own. You guys mentioned that we have this guys right here, which is object-oriented programming, and I'm sure that from previous courses you guys know what this paradigm is. It's creating objects. It's not telling the computer what to do for everything, but it's describing objects and their interactions. And by describing objects and their interactions, their traits, their properties, their behavior, whatever, we get the job accomplished. So that kind of programming is very different than functional programming, which is very different from, this is called imperative programming. Imperative programming, in which imperative programming, in a sense, we tell it what to do. We describe the algorithm. In imperative programming, what we're doing is we're actually writing in code the way to do or to solve the problem. We are using all kinds of commands and assignments, and we move the computer from state to state. And by doing that, we are slowly approaching the solution to the problem. In a sense, what we're actually doing is we are describing the algorithm in programmatical sense. And that's imperative programming. It's pretty much machine language is pretty much imperative programming. Other paradigms are different types of programming, but as I said, they all compile down to machine language. So at the end, there has to be a way of translating all these higher level type languages back to simple imperative terms. But the way the programmer approaches the problem is very different. If he's an imperative programming paradigm, object-oriented programming paradigm, logic, functional, or whatever. The guys that we have over here are pretty much script languages. Some would call them descriptive languages. And the idea is that we don't want to tell you how to do it. We want to describe the problem and let the computer figure out how to do it. That's where we're going. It's obviously not there yet, but the idea is that I don't have to go and say, okay, now loop, now do this, now do that. But I try to string together a whole bunch of, I would say libraries, but some glue language functions, and string together something that I don't want to describe the computer how to do it. I want to describe what my problem is and let it figure out how to do it. And that's more a higher level. It's imperative at a higher level. It might be also object-oriented, but these are known as fifth generation languages. Right? We have the machine languages, the assembly languages, and we have third generation languages. We have afterwards, which is imperative and stuff. Then we have the fourth generation, which is pretty much OOP, object-oriented programming and stuff. These are fifth generation already. And if you think about it for a second, every 10 years, in a sense, we have ourselves a new generation, meaning we had, for example, machine languages and symbolic languages in the 40s and 50s in the last time, 19th century, in the 20th century, 20th century. And then in the 70s, we pretty much got ourselves, in the beginning of the 80s, we got ourselves the imperative languages, things like Pascal and C and those kind of guys, COBOL and others. And then in the 80s and 90s, from the mid 80s, but pretty much through the 90s, maybe a bit further, we got ourselves our object-oriented programming. And then pretty much in the 2000s, the 21st century, I'm talking about the last 10, 15 years, we are dealing a lot with these scripting languages. Now, according to this, we're pretty much up for another paradigm shift sooner or later, because we're there already. So go know what the next paradigm shift might be. But if you look at it, we're pretty much seeing the development of languages over the years and how the paradigm shifts from one type to another type. Now, the last column here, which I didn't write, It's the language of I don't know languages, which means I didn't know in which I don't know these languages, and therefore I couldn't place them in any specific column. So since I do not know how to program in these languages, and I'm not sure what they were, I put them in a own column called I don't know, and every one of them obviously belongs to some kind of paradigm.